finish your last rep. You rack the weight. You feel nothing unusual yet, but something has already gone wrong inside you. Thousands of tiny tears have opened up along the fibers you just worked. Your body doesn't know this is a good thing. For the next 2 days, it treats you like you're injured. And the way it repairs that injury is the entire reason you grow. Here's what actually happens between the moment you put the weight down and the moment you look stronger in the mirror. Start with the tear itself. When a muscle fiber is loaded past what it's used to, the proteins inside it, actin and myosin, get physically damaged at a microscopic level. Not torn like a hamstring injury, more like a rope that's been stretched until a few strands fray. Researcher Brad Schoenfeld, who has spent much of his career studying why muscles actually get bigger, has shown that this damage is only one piece of the puzzle. It matters, but it isn't the whole story. Tension matters more. Time under load matters more. The damage is a signal, not the mechanism. So what is the signal telling your body? It's telling your immune system to show up. Within hours, white blood cells flood the area. This is inflammation, and it is not the enemy people think it is. Swelling, stiffness, that dull ache building already by the time you get home. That's your body sending demolition crews to clear out the damaged proteins so new ones can be built in their place. This is where the soreness comes from, not lactic acid. That myth has been dead for decades. The soreness you feel a day later, sometimes 2 days later, is called delayed onset muscle soreness. Your brain is registering the inflammation and the microscopic disruption as mild, ongoing damage. It hurts to sit down. It hurts to raise your arm above your head. But underneath that discomfort, something remarkable is already underway. Your body has cells whose entire job is to appear only when muscle is damaged. They're called satellite cells, and they normally sit dormant on the outside of your muscle fibers, doing nothing. The moment they detect damage, they activate. They multiply, and then they do something almost no other cell in your body does. They migrate into the damaged fiber and fuse with it, donating their own nuclei to help the fiber rebuild larger than before. Charlotte Peterson at the University of Kentucky has spent years mapping exactly how critical these cells are. Her research found that without functioning satellite cells, muscle can still adapt somewhat, but the ceiling on long-term growth drops significantly. These cells are less like repair workers and more like a permanent upgrade crew. Why would your body build something so specific just to grow bigger muscle? Because for most of human history, muscle was survival infrastructure, not aesthetics. The ability to carry, to climb, to run down prey or run from a predator depended entirely on how much usable tissue you could pack onto your frame and how fast you could repair it after use. A body that couldn't recover from physical stress didn't get a second chance at the next hunt. The satellite cell system isn't a modern feature. It's ancient hardware, still running exactly as it did 50,000 years ago, except now it activates from a barbell instead of a spear. Meanwhile, inside each individual cell, a different process is unfolding at the molecular level. Mechanical tension from the lift triggers a pathway called mTOR, short for mechanistic target of ripamycin. Think of mTOR as a construction supervisor. When it senses tension and available amino acids, it authorizes the cell to start building new proteins. Stuart Phillips at McMaster University, one of the most cited researchers on human muscle protein synthesis, has shown that this building process, the actual laying down of new contractile proteins, doesn't peak right after your workout. It peaks somewhere between 24 and 48 hours later, and in untrained lifters, it can stay elevated for as long as 72 hours. That means the workout isn't when you grow. The workout is the request. The growth happens while you're doing something else entirely. Sitting at your desk, watching television, asleep. Sleep is where the most important repair work happens, and it happens for a very specific reason. Growth hormone release spikes dramatically during deep sleep, and that hormone acts almost like a messenger telling the mTOR pathway to keep working overnight. Cut your sleep short, and you're not just tired the next day. You are actively interrupting the exact window where the muscle you damaged gets rebuilt into something bigger. This is one of the most consistent findings in exercise physiology, and one of the most ignored. So for 2 full days, your body runs a repair operation you're barely aware of. Damaged fibers get cleared out. Satellite cells fuse in and add their nuclei. mTOR keeps the construction crews building new protein structures. Fluid shifts into the area, which is part of why a muscle looks slightly larger even before real growth has occurred. None of this shows up as visible progress in the mirror. It happens too slowly and too internally for that. But cumulatively, workout after workout, the fiber that once tore under a given weight can now handle that same weight without any damage at all. That's the part almost nobody tells you. Adaptation means your body eventually stops treating the same stimulus as an emergency. The first time you lift a weight, your body reacts like you've been mildly attacked. Inflammation, soreness, a full 48-hour repair cycle. But do that same lift, at that same weight for the 10th time, and your body barely notices. No soreness, no major inflammatory response. It has already built the infrastructure to handle it without treating it as damage. This is why soreness fades even as the muscle you're building keeps getting bigger. Soreness was never a signal that you were building muscle. It was a signal that your body hadn't adapted yet. This is also why muscle memory is real, and why it isn't really about your muscles at all. Those satellite cell nuclei that fused into your fibers years ago don't disappear when you stop training. Some research, including work building on Peterson's findings, suggests these added nuclei can persist inside the fiber for a long time, possibly years, even after significant muscle loss from inactivity. That's why someone who trained hard in their 20s and stopped can regain their old size far faster than a complete beginner ever could. The infrastructure was never fully torn down. It was just left unused, which brings you back to that ache you feel a day after training. It isn't damage in the way you assume. It's proof that your body still runs on the same emergency repair system it developed when survival depended on rebuilding torn tissue fast enough to hunt again tomorrow. Every rep you do is a small message sent to biological machinery that is tens of thousands of years old, asking it to do the one thing it has always known how to do: rebuild, and rebuild bigger, just in case the demand comes again. You finish your last rep, you rack the weight, you feel nothing unusual yet, but your body already knows exactly what to do next.